So my name's Dave Ward, and I just wanted to give a quick update this morning on where we are with the FIDO community and where we're going. And I know you're all here for actually coding training, so it'll only be about half an hour or so, but it's price of admission, and I had to hear myself talk. So just a few stats on where we are, about a month and a half in, and as you take a look at this, actually the traction's really gotten quite large, which is surprising to me, with obviously about 450 commits from 52 contributors. To put this into perspective, in the first month, we had more contributors and contributions than either OVS or DPDK. Pretty cool. And it's always based on releases, but nonetheless, that doesn't prevent me from making grandiose claims proven through emphatic assertion. Couple of things. So when you leave out of here, you can see when the TSC calls and then when the VPP community calls are happening and the crews on all those calls as well. So this is how you'd begin to engage and ask questions as well as on the list and begin to set up projects that you want to move forward with and get into the release cycle. And I know, so for example, there's a few new projects already. The CSIT, and we'll hear from Maciek, he's on his way over, probably stuck in traffic right now, which is the Continuous Performance Lab and his entire framework. That is going to be open source and updates to that. Second is Honeycomb. That becomes a really key project for folks that are working on control plane. Remember, that's the agent on top of VPP that we will teach to speak every SDN protocol northbound to things like Open Daylight or whatever controller. And that speaks southbound to the binary APIs. So as you add new features and you create APIs and you put something into the CLI, you are not done. You're not done until you can speak with Honeycomb and have a standardized SDN way of speaking directly to VPP. And as we lay out release progression and as we lay out what's necessary to be a part of an official release, I just want to call out that Honeycomb becomes a key piece of this. And is Medved dropping by at all, Dave, over the next couple of days?
Don't know.
We might want to just drag him over here because Jan Medved, who many of you may know from Open Daylight, is the one who's also helping contribute to that Honeycomb project, and it would be good. NSH and service function chaining approved, and that's a multi-committer community project, and the overlay network engine. And as we move forward, what becomes very interesting, and as I mentioned perhaps during the launch of FIDO, is that we're looking to have VPP and this project be a full user space host stack, TCP IP stack. And so that when working with containers or when working with hypervisors, you need a few things like netlink. And so there's some great projects to work on in that space in addition to just features, which is a large part of the discussion today. So we just started talking about release planning. This needs to be in coordination to what projects can come in and what date, its conjunction with Open Daylight, with OPNFV, and with other projects as fast data stacks. So we do want to get into an alignment with other joint open source projects or places that we want to hit. Another target, for example, that we may be discussing over the next month is VPP's relationship to OpenStack, an ML2 plugin, and then understanding with that release cycle what we want to be able to target for functionality. As I mentioned, Open Daylight, Honeycomb is a project there, and the virtual bridge domain, which has a lot of VPP work that needs to be done, as well as a lot of Honeycomb that works to be done, and then fast data stacks, as Ed mentioned as well. We've got a bunch of events that happened recently or happening now. That should say the Hackfest, which is on April 2nd, not March 2nd. That just happened this week. And VPP and some hacking in VPP actually won that Hackfest at the IETF. So that's actually, it came in second, I think, with Ole Tron doing that work, and Pierre, wherever Pierre is, there he is, wave to the crowd. So congratulations, even though you're not in Argentina, you still managed to win. So you've been hacking a lot. Long flights from France do that. But really the point here, and a lot of the reasons why we open source VPP was to be able to tie to standards bodies and new protocols specifications that are being written, that there is a location that code can be written at the same time as specs. And so the IETF and its use there, and it's not its first time at an IETF Hackfest, and then MEF Hackfest or Metro Ethernet Forum are places that you'd be able to code in public with the community as well. And so obviously we've got this event. We are also in the planning stages of when we might have another one of these dev boots going on in Europe And Emran, I'm not sure if we solidified that date. We have?
No, we haven't solidified a date, but it will be sometime in May.
So we're looking at the first couple of weeks in May and doing this again somewhere in Europe. That includes the UK. We're from the US. We consider the UK part of Europe. Europeans consider the UK part of the US. It's confusing. But nonetheless, we'll see where we can do it, and it'll be where we can make it cost effective as well. So Maciek's going to cover what I'm about to just breeze through quickly in gory detail. And if you know Maciek, it's really gory detail. Love you, Maciek. But nonetheless, most of you have seen this publication that was done by eAntic last September. And this is some of the first claims. And we, of course, talk about a couple of ports of 10 gig and doing line rate for large tables. Most of you have seen that data. Some of you may have seen some of the newer data that was done for Mobile World Congress and beyond. And really what we want to show here is that we've tested 12, 14, and 16 40 gig ports and hitting 462 gigs and running out of NIC and PCI bandwidth. And although this is a slightly incorrect slide, depending upon the number of 40 gigs, when we get to a higher number of 40 gig ports on a 4-socket computer, we're actually at 307 million packets per second for L2, V4, V6. And just to hit on V6, that the table lookups, whether it's an L2 or L3, actually don't have any performance impact whatsoever. Same again, here's just V4. And again, Maciek's going to go into this in detail. And Maciek also has a little bit of updated data on this, looking at a 2000 whitelist input ACL. It's also at 462 gigs per second. So a number of folks had asked, what's performance like when you have ACLs and fib lookups, and it's still screaming fast. You do end up using more cores because there's more work to be done for VPP, but Maciek, it's on the order of a 20% increase in cycles. Is that about right? 15. Oh, sorry.
15, Dave. Get your numbers right.
You keep changing them on me, Maciek. It's challenging.
It's not me, it's computers.
Yes, you'll get a full talk by Maciek coming up. So this is one of Maciek's illegible screenshots. There's a misspelling on there. I hope you can find it. But really the point of taking a look at this is when we take a look at the amount of cycles that are necessary to fling IP packets through VPP, we really aren't using much of the horsepower of the threads. And in fact, we're using around 10% of the horsepower of the threads necessary to fling those packets. And so I want to translate that to you. That means that for the same data rate, you've got 90% of the CPU left to write features. That doesn't mean you're going to write bad code. That just means that we have lots and lots of headroom to actually write more features and still have the same performance. That's the explanation roughly of that one, and Maciek again will go into detail. This one is just a note. Again, the text might be slightly challenging to read on the screen, but what we've seen, particularly with OVS, is unbounded delay and jitter of flinging packets through OVS, and many of you may have seen that as well. And the delta is really the difference between greater than 120 milliseconds potential delay, jitter, and variance of flinging packets through OVS. And when Maciek ran a week-long just soak test, the largest outlier for VPP was 3.5 milliseconds. I released a blog yesterday, and where I'm headed with this concept is we're extremely close to being able to talk about deterministic virtualized networking. And that's actually quite a large deal in the industry if we can actually continue to have bounded delay, variance, and jitter through a virtualized forwarding stack to get to the point where we can do real-time or even real-time communications as well as uncompressed video flows through this. Because obviously if we drop bits and somebody's doing a video ingest, you get serious problems going on. So a few more things. A little bit of a teaser. What's interesting is that, and Maciek's going to again go into this gory detail, really taking apart the compute system as well to understand exactly what's necessary to be able to deploy with these types of performance numbers. What Damian and Maciek can explain on Thursday is that you really have to tune your computer to be able to make things go very, very quickly. And you have to know exactly how to utilize all the PCI lanes, how to make sure that the code is tuned to hit the specific CPU architecture and the cache architecture, And what would be interesting is if there was a project that actually had those knobs and variables tuned that you could, this is getting out there a bit, but if you could actually just load a specific configuration into a compute type and get these types of performance or very close to it, because otherwise it does take quite a bit of tuning to understand the differences of the specific CPU architecture. And frankly, most deployers may not know, may not care, may not want to deal with those details. So as we move forward, what I think everybody realizes and what you're going to see with a Mac switch example that you're going to talk about today. Is that correct, Dave and Keith? Okay, Keith is going to walk through. Number one thing that we've been asked is, how do I build a feature node in this graph, and how do I load it, and how do I make it work? And that's pretty much the majority of the day. Is that correct, Keith?
Correct.
Yeah.
And so Keith's going to go over slides like this, but what it turns into and what we hoped for the community is that much of the community will focus on building specific feature nodes versus necessarily having to work through a lot of the infrastructure, which is pretty sound and stable. And the sub-projects of the community actually become those independent feature nodes that people want to build. And the ability to load and unload those on demand as part of a running system becomes very interesting, and also part of how CSIT's going to work and how that continuous performance lab is going to work. So this slide's been put up a few times, which is a high-level summary of the features that are currently available. Actually, the gory list of detailed features, I think still really probably needs to be extracted from the code and written down very clearly. It's one of those things that, as Dave's worked through time, they've just been added and we haven't necessarily listed them all out, but this is the feature set that's under basic support. And I call out this piece because if you work with other virtualized forwarders, they don't have counters and mandatory input checks on by default. And all the performance work that Maciek is doing includes all of these checks turned on. Dave is going to go through also some examples, or Dave and Keith and the whole team, of how to do telemetry, how to build counters, how to build export of those counters, which is what we summarize as telemetry. And what becomes interesting is that other virtualized forwarders, and again, I'm referring to OVS in both of these, not only don't have mandatory input checks turned on, don't have any counters turned on. And when you go and get into deployment, into operations, and you want to know what's going on, did I deliver that service that somebody paid for or somebody wants, you generally prove that through counters and OAM. Whether or not we need a project to big train switches to turn on and off counters for the highest level of performance, the community can decide, but right now counters are on. And so there's no doubt there's a performance hit for having counters on, and it's only for racetrack testing that we'd want counters to be off, but nonetheless, they're on at all times at this point. And Dave, you can walk through that when you do your telemetry exercise. Other possible projects, load balancers, HTTPS application routers don't exist, and here I'm talking about, let's say, going after Go Router and Cloud Foundry, if that's of interest to the community. Loading in firewall modules, and you can read this instead of me reading each one of these pieces. There's a ton of stuff that can be done here and a ton of ways that folks can express themselves and innovate. And these are just a few suggestions that we had. What becomes interesting on the OAM piece, and a colleague of ours, Frank Brockner's, who's been leading the way, and actually the V6 OAM that's in VPP was a spec of his. What becomes interesting is if we can actually move the industry away from a tapping architecture to understand performance inside the network and performing OAM, and instead have VPP as an OAM appliance and use that to check links, check component links. It's something that's just not seen in the industry today, that there's actually OAM appliances that can test topologies and test networks out there, both from correctness but also load and PPS, et cetera. And I think that would be of huge benefit to the industry. So as we move forward, just quickly, I wanted to lay out a couple of pieces on, again, why we open source VPP and where I'd like to see this personally go. One is into an OpenStack architecture. Now, this is not the existing OpenStack architecture Neutron, in which Open Daylight has been brought in as a centralized state maintenance location over a service chain. But nonetheless, this is one that we're working towards inside Cisco, And we all, as a community, can actually have a direct ML2 plugin directly to VPP in the traditional OpenStack model. The problem with writing something directly into a traditional OpenStack model is you didn't fix anything with OpenStack. And what I mean by that is if we're focusing on virtualized or network function virtualization and building VPP as a virtualized network function, then that state maintenance of that service chain that you're trying to build, if you've tried to do this in OpenStack before, you know that you have a distributed state maintenance problem, you know that you have a high availability problem if things go down or if things fail, and it's really quite painful. And a few of us kind of stepped back and said, you know, if we actually had an SDN controller that knew service function chaining and that could do the centralized state maintenance over the service function chains, that might be a very good architecture to go forward with. And so in the Open Daylight community, Keith and others have been working to build out group-based policy and build that into an OpenStack plugin and really advance the capabilities of doing service function chaining and NFV and OpenStack via Open Daylight as that centralized controller in that architecture. Again, I'm not trying to necessarily dissuade somebody from building an ML2 plugin for VPP, but in addition to that, we also need to take a look at service function chaining. The main target that I have with our group here is actually towards container networking. And the reason why I say this is if you work with containers, you realize that applications running in containers, by definition, use the operating system services of the host container. That includes the Linux kernel networking stack. If you've worked on computers, you know that the electronic state of the kernel, the state of the kernel determines the electronic state of the computer. There's a high availability problem. As networking engineers, we also realize that we need full flexibility to add any features that we need at our pace, as well as hardware acceleration support, whether it's security or it's regex or it's any offload that we need that's available in a NIC or SmartNIC. And that often is most easily done in user space versus kernel space. Not to mention that there's a certain tendency in the Linux kernel networking community for not enabling proprietary hardware support in that kernel for the networking stack. I don't have that religion, and this isn't a religious debate. It's just that if there's a tool in the industry that we can use to make deployment better as well as to make the network go faster, I want to be able to utilize all those. And the plug-in architecture of VPP for that hardware support works out very well. So the goal that I have through calendar 16 and 17 with my group actually is towards moving container networking forward, potentially getting beyond just tap interfaces or tap-ton interfaces if you're familiar with that architecture. And if we do this in user space, we can bring all of the PCI lanes that we want associated with I/O and dispatch out of VPP versus dispatch out of the kernel. And there's much more that we can talk about there as we work as a community to plan this out. Service function chaining becomes key, and I mentioned this part of the OpenStack piece. But in reality, the recent release of Open Daylight contains group-based policy and service function chaining integration together. And with NSH and service function chaining available in VPP, it now has a forwarding plane to talk with that fully supports it. And building out virtualized network functions in chains and being able to fire these up extremely efficiently is very much a target for us in the industry as well, and keeping it all in open source. But VPP also can just be a straight up virtualized network function. And that's a lot of the work that Pierre has done and Ule Tran has done and others have done with, for example, support of every known 4 to 6, 6 to 4 translation mechanism that's been spec'd out at the IETF and full support of that. And that means that it can be a map server, mapping from V4 to V6 or V6 to V4. And it functions perhaps as one of the highest performance virtualized network functions that can be done. And this is merely a matter of more features being added into it for the virtualized network function that you're looking for. There's a number of other pieces that need to be built such that VPP can be used within these environments. And these are great potential projects for the community. And then just giving you a preview of some of what Maciek's going to be talking about with the Continuous Performance Lab. The reason why we took this to the Linux Foundation and built a foundation around it isn't because we all love foundations or we love giving money to support things, but in this case, the experiment is different with Fido that with every check-in and with every release, we'd like to guarantee performance and scaling of the forwarding plane and of that feature. And as far as I know, this is the only open source project that has support for a continuous performance lab and continuous functional testing, of course. So the last piece, there's a whole bunch of stuff available online for follow-up after this session. Videos of Dave. Excuse the language. If you've already heard Dave speak, you understand that he has copious use of the native Irish tongue. And as well as there's tutorials, documents, and more stuff headed up online.
These guys have already heard all of my jokes, so I'm trying to
Oh, they're
put a lid
horrible,
on
Dave.
it for the.
Please. Anytime he gets in front of, we don't let him out very often, and so I've known Dave for 12, 15 years, and they are the same jokes as they were 15 years ago. So.
Wow.
So I did that at a pretty high baud rate, and these slides will be available, but I just wanted to let you know a preview of where we've gotten so far in the first month and a half, some of the targets that we have, and hopefully some of the targets that you can take on as projects in the community. So thanks, everybody. I'll talk to you soon.
See you, David.